Okay, we just wanted to give a real quick tour of the new DuinoKit IoT learning kit that we have, and just a brief explanation of some of the parts and things that you'll encounter when you're on the kit. And we'll start up here with a 9-volt battery supply. Right now I have an alkaline battery in there. There are some rechargeable LiPo 9-volt batteries that can fit in there real nicely if you want to keep using the set and not toss away batteries. Next to that is a auto on and off module. This will be used in our project so you can actually have this shut down completely. ESP32 also has a low power setting which will allow it to go into a deep sleep mode, but still consume power. This can do a total shut off. That's also available as a separate module. We have two different buzzers, an active and a passive buzzer, and a OLED display up here, and then of course some LED 8 displays, and these two are hooked into a shift register so you can control all of these 64 LEDs on this number display with only a couple of pins from your microprocessor. And then we have a 64 and 8x8 LED array here, and those are also hooked into a shift register, which is how you usually find those modules assembled. We have a infrared transmitter and receiver, along with a RGB LED and 3 arrays of LEDs. This one over here is an addressable LED, which is like those strips that you see in all of the lighting modules where you control each one individually with color, and we'll use that in a couple different projects. And then coming back over here, we got some discrete components, capacitors, MOSFET transistor, NPN, PNP transistors, a couple different diodes for our projects. Have a ultrasonic distance module. This actually transmits a sound wave and it bounces off an item and can measure short ranges on this particular module. We have an accelerometer, so it can know movement as the kit's moved or as your project is moved. You can calculate acceleration in 3 axes. Digital temperature and humidity. We have 2 potentiometers, more commonly known as volume knobs. There's also a rotary encoder. This one's got a push button switch on it. And a 2-axis joystick. That's also got a push button. That's like used on your Xbox controller. We got some buttons and LEDs up here, which we'll use for a Simon game. These here are also touch pads, and they're wired up here to these connections. And there's 2 of them up here, pads 5 and 6, where you can use that to touch with your finger to get conductivity between them, or these we can actually use as a conductive touch. The holes in there are made for the alligator clips, which came in your wire pack, so you can hook them on there and actually run the wires off of your project and hook it on different things. So if you want to use capacitive touch or use those sensors or connections to hook alligator clips to your projects, and those are included. Got an array of resistors, and in that array is a thermal resistor which changes value as the temperature, and there's a photoresistor which does the same as light levels change. It will change the resistance value, which we can read by the microprocessor. And coming in next to that, we have a DS1307 real-time clock. So this battery is in here to remember the date and time and keep that in memory. And again, touch pads, all of these wires go down to the 4 panels down here, or the 2 little touch pads up here. And of course you have your ESP32 module, which is the main brain of this, which is what will be programming to interact with all of these different sensors. We've also included a GPS module, so you can know your location and get the time anywhere on the planet. You know where you are and calculate the local time. Got a relay module, which will be able to power the relay. This is if you wanted to add in a higher voltage control of something. That's the little clicking that you hear in many devices when they turn on and off. We have an infrared motion sensor, of course a 4x4 keypad array, a 1602 liquid crystal display. We got a DC hobby motor and a controller hooked into that. Actually, it's got the wires that you will hook into, so we'll run the jumpers. It's not tied together, but I wanted you to learn how that controller chip works, the L9110. We have a stepper motor, which is wired into the controller here and plugged in underneath the circuit board, and a micro servo. And that will pretty much take you through the case itself. Along with your kit, it should have a USB cable for connecting to the microprocessor. You should have a couple bundles of wires. There should be a bundle of 20 long wires, and then 2 bundles, 65 pieces of shorter wires in your kit. There's a spare microprocessor because yes, these can be burned out. So if you run into problems with that, or maybe you put a program in there that you want to keep on there, you can plug in the other microprocessor. This is the only part on the board that is removable. So it just plugs in. It's kind of a snug fit. Make sure when you're putting that in there that you line the pins up correctly, and it should just drop right in. Make a good connection. And the last thing you have in your kit is your package of alligator clip wires. The only thing you might need to dig for in your package is this little clip of connectors, which typically go on the micro servo over here. I already put one on there. I just put a little one-way horn on there so you can just see direction and movement. There's also a little hexagon on this motor so you can feel how fast that's spinning. Again, it's made for prototyping, so sometimes you just need to know which direction it's going, or be able to see that. And then there's a pointer on the stepper motor that you'll be able to see as that steps and turns around. So that's a basic introduction to the components, and then we'll be making some projects on these, and I welcome any projects you have or questions you have, and maybe we can make some videos and tutorials to help you better understand the DuinoKit IoT and the ESP32 chip and how to make projects.